Hi everyone, welcome back. The learning goal for this video is given the formula of a molecular compound, you should be able to write its correct name, or given the name of the molecular compound, you should be able to write its formula. So in this video, we're primarily focusing on molecular compounds, which we will refer to them as covalent compounds, and that's where electrons are shared. And the names of these molecular or covalent compounds need prefixes because several different compounds can be formed from the same two nonmetals. So for example, carbon and oxygen are two nonmetals, but you could have two different molecules using carbon and oxygen. You could have carbon dioxide, or you could have carbon monoxide. Molecular compounds form when atoms of two or more nonmetals share electrons to form a covalent bond. So whereas ionic compounds was a complete transfer of electrons, for covalent compounds or molecular compounds, they're sharing electrons. Those valence electrons are shared by nonmetal atoms in order to achieve stability. And a molecule forms when two or more atoms share those electrons. And this will be a core chemistry skill, the ability to write the names and formulas for molecular compounds. So when naming a molecular compound, the first nonmetal, you use its full elemental name. The second nonmetal is named using the first syllable of the name followed by IDE. Now, if you have a subscript indicating two or more atoms of an element, a prefix is shown in front of its name. And the prefixes used in naming molecular compounds are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. As stated on the first slide, several compounds may be formed from the same two nonmetals, so that's why it is important to use prefixes. Here, the first element's carbon, we use the full name of the first element. The second element's oxygen, we use the first syllable and then add IDE, so oxide. Because there are two, we have to put a di in front of oxide to indicate two oxygen atoms. So this is carbon dioxide. CO, we can see carbon, and then the second element, oxygen, once again is oxide, but we have to put mono in front of it, and so we have monoxide. So the number of oxygen atoms present is indicated by the prefix. And when the vowels O and O or A and O appear together, the first vowel is omitted. So for example, this monoxide, you may originally have written MONOOXIDE. But we drop the first vowel, and so that's why it becomes monoxide. Something else to note is that if the first element in the molecular compound has only one, then we do not include mono in front of that element's name. So notice how we don't have monocarbon dioxide. But if the second element has only one, we need to include mono. So this is carbon monoxide. So here are some common molecular compounds. So for example, nitrogen oxide here actually technically should be nitrogen monoxide. So let me write that up here. So this would be nitrogen and then monoxide with that prefix. Same thing here, nitrogen monoxide, dinitrogen monoxide. This nitrogen monoxide is used as a stabilizer and it's a biochemical messenger in cells. Here we have sulfur hexafluoride. And so this is used in electrical circuits. Dinitrogen monoxide is used as laughing gas. So let's go through some guidelines to naming molecular compounds. First, name the first nonmetal by its element's name. Name the second nonmetal by using the first syllable of its element name, followed by IDE, and then add prefixes to indicate the number of atoms. So let's do an example together. First, I recognize nitrogen as a nonmetal and chlorine as a nonmetal. And so we are going to need to use prefixes for this covalent compound here. The first element, nitrogen, I use the full name. The second element, chlorine, I drop the I and E, keep the first syllable and replace it with IDE, so this is chloride. I have one nitrogen, which would be mono, but we don't need to include mono for the first element in a molecular compound's name. This one here, I have 3, and so what's the prefix for 3? Tri, good. So then if I write the name again, this would be nitrogen trichloride. All right, try this one on your own first and then check your work with me when you're done. All right, so we see here we have boron, that's a nonmetal, and oxygen, a nonmetal. So let's write boron, the full name here, and then oxygen, we need to convert it to oxide because it's the second element written. There are 2 borons, so what's the prefix for 2? Di, and what's the prefix for 3? Tri. So then the name would be diboron trioxide. And we do keep those 2 vowels together. I know. All right, here's the guide to writing formulas from the names of molecular compounds. So if you have the molecular compound name, writing the formula, first write the symbols in order of the elements in the name, and then write the prefixes as subscripts, since they indicate the number of atoms for that covalent compound. I want you to go ahead, try to do this one on your own first, and then check your work with me when you're done. All right, this is diphosphorus pentaoxide. So phosphorus is P. So we want to use that one. I always want to show this to students. Sometimes it can be confused for potassium. Both start with P, but potassium is K, phosphorus is P. So we have P, and you write that in the order. So phosphorus, and then oxide is O. We have P and O, and then diphosphorus means how many phosphorus atoms? 2, and how many oxygens? 5, good. So diphosphorus pentoxide. Remember originally the prefix for 5 is penta, but if we have an A and an O together, we drop the first vowel there, the A, and that's how we derive pentoxide. All right, let's bring our knowledge from the previous video and our knowledge we just learned in this video together in order to name compounds whether they're ionic or covalent, because there's two different naming systems for ionic and covalent compounds. So first, the thing you'll need to do is identify if a compound's ionic versus covalent or molecular. So ionic, if the first element in the formula of the name is a metal, or the polyatomic ion ammonium. So for example, if we have K2O, we notice K, which is potassium, and that's a metal. So immediately you know that the compound's ionic, and you'll want to follow the ionic system for naming. Covalent, if the first element in the formula is a non-metal. Now be careful, make sure it's not ammonium. But if it's not, like in this case here, N2O, seeing that nitrogen's a nonmetal, we can assume this compound is covalent. Once again, dinitrogen monoxide. We should include that mono there for that name. So let me read that here. Dinitrogen monoxide. Here's the flow chart we saw in the previous video. We walked through the naming for ionic, and now you have the second portion of this flow chart for molecular compounds, covalent compounds that contain two nonmetals. That first nonmetal, we use the prefix to match the subscript before the element's name, but we can ignore mono for the first one. For the second nonmetal, we use the prefix to match the subscript before the element name and end with IDE. All right, go ahead and pause the video, try to do the study check on your own, and then check your work with me when you're done. All right, so I see here silicon. So this one we are going to treat as, it is technically a metalloid in the middle there, but we're going to treat it almost like a non-metal there. So, and then we have chlorine, which is a nonmetal. So we will need to use prefixes here. So this will be covalent. So when you're working with metalloids, treat them more like nonmetals in terms of naming and identifying as ionic or covalent. So this one is silicon, and then because it's covalent, we need to use prefixes. And there's 4 chlorines, so that would be silicon tetrachloride. So the answer is C. So there's 4 chlorines, so the prefix goes in front of the chlorine. But remember the second element, we drop, we keep the first syllable and then drop everything else and replace with IDE. So that's why it turned into tetrachloride. Here we have phosphorus and oxygen. Phosphorus and oxygen are both nonmetals, so we're working with covalent. And that means I need to use prefixes. There's 2 phosphorus, so the prefix for 2 is di. So immediately I see, oh, it must be this one here because these don't have the di there. And then for 5, it should be penta. So this is diphosphorus, full name for the phosphorus, and then pentoxide, because that's the second element. So the answer is C. And then the next one, we have chlorine and oxygen, 2 nonmetals, meaning that we're working with something that's covalent. And so therefore we need to use prefixes. And therefore I need to use the full name of chlorine here. So dichlorine. So I see it could be one of these 2 here, not this one. And then 7 oxygen. So how many is 7? Or what's the prefix? Hepta. Because it'd be heptaoxide, we dropped the A, it turned into heptoxide. So the answer choice is A. Dichlorine heptoxide. All right, let's practice our knowledge from the utilizing our knowledge from the previous video with this video here. And I want you to pause the video, try to identify each compound as ionic or covalent, and give its correct name using the correct naming system. All right, so coming back here, it looks like we have sulfur and oxygen, both of which are nonmetals, and therefore this is a covalent compound. A covalent molecular compound, so that means I need to use prefixes. The first element's name, use the full name sulfur, and then oxygen turns into what? Oxide. And how many oxygens do you have? 3, and so use the prefix tri. And so this is sulfur trioxide. So once again, remember the second element, you use the first syllable, so ox in this case, and then replace everything else with IDE. So that's where we got the oxide. Now don't confuse SO3 with SO3 2-. Now SO3 2- is a charged polyatomic ion sulfide. So be careful with that. Sometimes students see SO3 and automatically think polyatomic ion, but this one doesn't have an overall charge. So this is a different compound than this polyatomic ion here. All right, we have BaCl2. So Ba is what? Barium, which is a metal. So therefore, is this compound ionic or covalent? Ionic. And that means no prefixes. And I'm being intentional about writing this down because more often than not, when we're first learning this naming system and all these rules, it can get quite confusing. So sometimes I'll see students use prefixes for ionic compounds. Sometimes I'll see students try to use Roman numerals for covalent compounds. So try your best to keep that flow chart in mind and keep organized of when you need to use what. For example, prefixes only for covalent compounds, Roman numerals only for transition metals. So those sorts of details you want to have organized. All right, so with ionic, remember we use the first name or the first element's full name, barium. And then we also do this is where there is some overlap here. That second element, we use the first syllable and then replace the rest of it with IDE. We ask ourselves, is barium a transition metal? Nope. So do we need a Roman numeral? No. And no prefixes. So this name for this compound is just barium chloride. All right, next one here, a bit of a trick question here. So we see here, you may be like, oh, that's a nonmetal, but this is ammonium, the polyatomic ion. And so this is a cation, and we learned that PO3, 3- is phosphite, which is also a polyatomic ion. So because we're working with a cation and an anion, this is ionic, meaning that there's no prefixes to worry about here. And with polyatomic ions, like we learned in a previous video, we just use the full name as is. So for NH4, that's ammonium. You don't have to change it. And PO3, that is phosphite. So this is ammonium phosphite. No prefixes, no Roman numerals. This is its name right here. All right, Cu2CO3. So Cu, that's copper, which is a transition metal. So immediately we know if there's a metal, it's ionic, and we don't have to worry about prefixes. But we definitely need to worry about Roman numeral because we have a transition metal. So we don't want to forget. So a lot of times when I'm working through problems, I write notes to myself. So you don't forget to do that. So with that being said, I don't know the charge for copper. So I'm going to write these notes down here. So copper, I don't know. CO3 is a polyatomic ion. Remember, you'll be provided the list of polyatomic ions for in-person assessments, so no need to memorize, but make sure you're familiar with them so you can look them up quickly if needed. So this is carbonate, CO3 2-. And so if I do the algebra, I have 2 copper atoms, here ions. X is the charge. I have 1 carbonate with a -2 charge. Remember that the 3 is for the oxygen. That's part of the polyatomic ion. And there's no parentheses, which implies that there's only 1 carbonate. So be careful with that. Sometimes you see students want to put 3, but that's part of the formula for the polyatomic ion. And there's only 1 in this ionic compound here. So that's that 1 there with a -2 charge. And remember that all ionic compounds are 0. So needs to set it up equal to 0 because it's neutral. So we have 2x minus 2 is equal to 0. 2x is equal to 2. And then x is equal to 1. So the charge for copper, we'll write the full name for copper, is 1, Roman numeral 1. And then remember the polyatomic name we just use as is. So this is copper 1 carbonate. All right, the next example here, we have nitrogen and then oxygen, 2 nonmetals. So we're working with a covalent compound. We need to use the covalent naming system, which utilizes prefixes. And so you write the full name of the first element. So in this case, nitrogen. The second element, we use the first syllable followed by IDE. So that would be ox and then IDE, so oxide. How many nitrogens do we have? 2, so we use the prefix di. And how many oxygens do we have? 4. So we use the prefix tetra, but remember with the A and O, we drop the A. And so it ends up being tetroxide. All right, thank you for watching. And as always, email me with any questions.